Okay, good morning all. Am I audible to you? That's great. Okay. Now, what uh, we are, we will continue with that is instruction format of 8086. Like I told you that we write it in assembly, right? But it should be converted to machine code, that is a binary code that machine can understand. Right? It is not going to understand move. It is not going to understand uh, various instructions that is and or not. So that is, it is not going to understand it, right? So what it will do, that it will convert it. We have a assembler. What it will do, it will convert it into the machine code. It will convert it into, right? So how it converts it, that is that you will learn that how it actually manages it, what is the job of assembler, that and the compiler is there, right? And compiler and assembler, how they are different and how they work, that is a separate subject to learn, right? So in future you might study that how assembler work. Definitely you are going to learn about compiler, but assembler will be a portion of that, right? For further study you can, but you will be in that state that you will be able to carry forward the further discussion. Of course, that is what is the point here, that how assembler works is out of scope of this subject, right? That you will learn separately in the other subject. Right now, what we are going to learn, suppose that assembler works, how actually it will encode, what will be the process of encode, how it will understand it. So we are going to do hand coding. Two methods, that assembler does it automatically or we can do it manually. Manually, that is hand coding, right? So today we will learn about the hand coding of instructions, different instructions. Right, we'll start with move instruction. We will learn about move instruction. Other instructions are done in similar manner. So what is today's agenda? First of all, to learn about instruction format of certain instructions, right? Hand coding of that, uh, right? So it is from assembly language to machine language translation. Then after we will go for jump instructions, near, far, um, short, different type of jumps are there. So that we will learn branching and looping. We are moving towards. That is today's agenda. Okay, so let us start with this instruction format. So whenever you write, you write your instruction move, right? What are the options that you have? Whenever you write move, right? If I write move instruction, what are the option I have? That what can be my operands? Do you understand opcode and operands? What is opcode and operand? Suppose I write here like AX, and if I write it as like 1, 2, 3, 4. Yes, these are the options. That is true. That is true, Jenny. Memory to register, register to memory, register to register, and immediate one. Immediate is also remaining. That what I have written is immediate one, right? So immediate to register, immediate to memory is also the combination possible. Okay, so so let us start with this here. So that is true. General is correct here. What are the options that I have, that I can transmit from register to memory or memory to register? That means data transfer between memory and register, data transfer between register and register, right? That is the second option that I have. And third option that I have, that register or memory and then immediate data from that. So register to immediate data is added, right? And then memory option also we have. So I'm going to start with this topic, that how I can, what will be the coding if I want to immediately transfer this data to a register? What will be the encoding of that? Okay. What about what is opcode and operand? Do you understand what is opcode and operand? Opcode is what? That it denotes the. In this, can you tell me what is opcode here? Which one is opcode? Do you understand that opcode word? Operational code. Yes, it is. It is. It is. Yes, it is. Move is your opcode, right? Suppose I write add. I am writing add AX BX. What is opcode here? Yes, add is opcode. So can I say actually, if you will observe it properly, that opcode instructs what kind of operation to do? What kind of operation to, here you have to add, here you have to move. So can I say actually opcode is operational code that is gives you idea to which operation to do. That is what is opcode, right? So that's true that add and move are opcode. What about operands? Over which that operation has to be performed. So in this case, can you tell me what are the operands over which the operation has to be performed? So operands are AX and BX. Here operands are, this is the data. Okay, this data that has to be moved here. So can I say both are operands here? Right? So these are operands and this is opcode. Two operands here, two operands here. Right? This is 16-bit operand and this is a register. Right? In that way, you can continue it. So these are the words which this is a terminology which might be useful to us. Right? So now, what is the instruction template? Now every instruction has a template in which, see, if I have a move, right? Move has its own template. In that, if I am having, okay, this is, I am taking one case, that register to immediate to register transfer. Can I say this is one instruction? Another instruction possible is move BX 1234. Can I say this is the same type, but instruction is different here, right? So this is also immediate to register transfer, but what will happen here? This instruction is different. This has to be separated from this. This code of this two must be different, right? Otherwise, how processor will come to know that you have to move to AX and here you have to move to BX, right? So what is the case? Like every instruction has its template in that, like it is a template of move, right? Now how the template in that certain spaces will be there that will specify that register will be AX, it will be registered to immediate transfer, right? And you also have like move AL 123 1 AL 12. This is also immediate to register transfer, but here it is 8-bit, here it is 16-bit. So what is the case? Like whatever the options that you are having for move, that options you can accommodate in that template, right? That will be template for what? Immediate to register transfer. But in that, what are the options that we will have? Whether it is 8-bit operation or 16-bit operation, whether it is for AX, BX, CX, or it is for SP, or it is for SI. So many registers are that, right? Then so that is what all about machine code. Now what is the template? Let me show you the template. Template is first, it is first byte. In that first byte, this is for 1 2 3 4 5 6 and 7 and 8. These are 8 bits. In that first 4 bits are 1 0 1 1. These are fixed. If you encounter first 1 0 1 1, that means it is move instruction, that you can understand. This is fixed in the template. This value is fixed. Okay, this is what, this is your byte 1. This is your byte 1, right? Okay, fine. Now in this first, this is fixed, these values are not altered, right? Now there is a W bit and there is this 3 bit. This 3 bit are for REG. These are 3 bits are register bit, and this is for this is W bit is for I will tell you, this is one W bit and this is register. These 3 bits are for register. Okay, what this W indicates? If W is equal to 0, it indicates 8-bit operation. W0 indicates 8-bit operation and W1 indicates 16-bit operation. That means for this instruction, can you tell me what will be the value of W? Quickly. Yes, it is going to be 0. Yes, it is going to be 0. And for this instruction, W is going to be 1. What about this register? What do you think what it is? What are the combinations possible for these 3 bits? How many combinations are possible? 8 combinations are possible. So they are for 0 0 0 to 1 1 1. right? Suppose it is 000, then you have to check this whether W is 0 or 1. If W is 0, that means it is 8-bit operation. That means these 3 bits are indicating register, but register will not be 16-bit because W is 0, it is 8-bit operation. So 000 will indicate AL, right? Then 100 will indicate AH. Why AL and AH? Because it is W is 0, that is 8-bit operation, right? So same way 001 will indicate BL and 101 will indicate BH. Sorry, it is little bit different. Once this 001 indicates CL, it is CL, and 101 indicates CH. Then DL for 010 and then DH. Yes, it is fixed that. So see, yes, if your machine encounters 000, then it is AL. True, it is fixed value. You cannot alter this. Okay, and same way, if you will go for 1011, it is BL, and 111 is for BH. I can show you that properly if you want to see. This is not a properly written, but anyway, it is written here. Consider like this, slightly like this. So what it is, 000 AL, 001 CL, 010 DL, so on, right? And suppose W is equal to 1. Suppose W is equal to 1, then 000 indicates AX, and 1 in that AX, then CX, then DX, and BX. AX, CX, DX, BX. So for this 000, it is AX, 010 CX, 010 DX. So this you have to remember. Okay, so here it is just a machine code, that is how it is converted, right? Okay, and then what is the next? What about remaining ones? This you can remember. This you can see here is SP. That SP, for SP it is this 100 for SP, 101 for BP, 110 for SI, and 111 for DI. Okay, so this is how these 3 bits are uh, 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 covered. So can you tell me for this what will be the value of AX here? I mean, what will be the value of W bit, and for this instruction, what will be the value of W, and what will be the value of these 3 bits? If you want this table, you can have this table. What will be W here for this instruction? Yes, W will be 1, and this will be AX is for 000. See, AX is for, actually this is misaligned. I will correct it, but this is misaligned. This is for 000. That's why I was, yes, it is 100. Yes, it is 100. AX is for 000. I mean, 000 is for AX, right? So this will be, yes, 1 and 000. True. So what we have covered till time in byte 1, what we have covered? We have covered it is a move instruction, and we have covered it is register. Register will be AX, and it will be 16-bit operation. That we have covered so far. What about this 1, 2, 3, 4? What about 1, 2, 3, 4? See, it is remaining. So right now, what we are concentrating on, right now, you see, everything will come. Janil, have patience. Right now, what we are focusing on, immediate to register transfer. That's it. That's it. On that we are just working on. For the different template is there. Okay. So right now, for this, let us focus so that we can conclude it quickly. What about 1, 2, 3, 4? That is remaining to mention. This is remaining to mention. Okay. So can you tell me how many bytes will be needed to represent 1, 2, 3, 4? 1 byte, 16 byte, 2 byte. Janil Keval, focus. Yes, Kenil, 2 byte. True, 16 bit. If it is earlier, if you, I mean, and 16 was the answer, but here it was 16 bit, right? It will, yes, it is 2 bytes and 16 bit. True. Okay, so that is true. Now, what about the cases? Um, Fine. So now what we are having here is, so yes, so it is 2 bytes are needed. So I am writing those 2 bytes. So 1 byte, one more byte is needed and one more byte is needed. So these 2 bytes are specified byte, byte 2, this is byte 3, right? Now can you tell me what will be the data here? Will it be 1 2 or it will be 3 4? How machine will interpretation? What will be the machine interpretation of 1 2 3 4? Will this be, yes, it will be 3 4 and 1 2, because this is how it will store it, right? So 3 4 and 1 2. Yes, so it will be 3 4 and 1 2. Though it is 1 2 3 4, but it will be 3 4 and 1 2. So let me write the entire code here properly. So how this will move is coded, how this move is coded. So for that, 1 0 1 1 fixed one, then W is 1 because of 16-bit operation. Register was 0 AX, so this is 0 0 0, right? Okay, then what about 3 4? How it is coded 3 4? So 3 4 is 0 0 1 1 0 1 0 0. So this is 3 4, right? And 1 2 will be how it will look like. So it will be 0 0 0 1 0 0 1 0. So this is how the entire move instruction is coded to uh, arithmetic, or rather I should say I mean, not arithmetic, but I should say in machine language, a binary translation. Okay, now how it will look in memory? Suppose this will get stored in code segment. This will get stored in code segment and offset IP. So here it will be CSIP value, whatever it is. This instruction is that, and it is stored in memory. So what will be first byte, second byte, and third byte? So this is the first byte. It will be B. What is that? What will be this? It is B and 8, B8. This is B8, and then this is 3 4 and 1 2. Do you understand why it is B8? One location is B8, second location will be 3 4, and then location will be 1 2. Okay, so this is how it is stored. Okay, now quickly tell me for move AL1 to H. Move AL1 to H. Give me the code for this. How it is different? How many byte instruction it is? How many bytes here? It is 3 byte instruction, right? You needed 3 byte, 1 2 3. Now it will need 2 bytes. Last time you were confused that how many bytes instruction it is for any instruction. This is how it is decided. Yes, you are correct here. It is 2 byte instruction. True. It is 2 byte instruction, and what are those 2 bytes? So let me know the code. This type of codes, let me know. It is 0 1 0. I mean 0 1 1 1 0 0 0 0. True, and then 1 and 2. True. So can you write it in hexadecimal here? I think you can understand it. Just only thing is that this will be 0 and this will be all zeros because of AL, and this will be 1 2. Can you give me the hexadecimal code? Yes, it is B012. Yes, it is B012. So it is 2 byte instruction, and what is stored? It is B012. Okay, so this is how coding takes place. Okay. B8. Okay, this are you clear with this will be my first byte? So what is that? This is B and this is 8. Comfortable, Jenny? This is 8, na? What is hexadecimal code of this? It is B8. Just to write it here, you can write it this code as well, right? But readability will be better if I write hexadecimal. Otherwise, okay, this is what is stored in first byte, second byte, and third byte. Okay, everyone is clear with this B8 and all those things? Should I move because next level is little bit more complicated? Okay, Jenny, that's great. And what about others? This next stage will be little bit more complicated than this. So you must be clear with this at least. This is simplest one. No. Yes, you can say not for entire move, but register to register transfer. Right? I mean immediate to register transfer. This is fixed for immediate to register transfer. Okay. So yes, B is not only for move first thing. No, 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 no. See, B this 1011 is fixed for move, and that too what we can say that too for register to immediate transfer, and just only based on B you cannot take decision. B can be used for other instructions as well. So it is not fixed for move, it is not fixed for every, that depends on instruction to instruction, it varies. Okay, for move even I will take the next case where it will be register to register transfer or memory to register to memory transfer, right? In that case B will not come. So it is not fixed for move even. So it is not fixed for every instruction. Okay, but again, just 4 bits are not sufficient enough. But yes, if you are encountering this 4 bits together, then next interpretation can be based on that. But again, if this is one and next bit is particular, then another instruction kind of things are possible. Right? But we are not going in that complications right now. But for register to immediate to register transfer, yes, B is fixed. Okay, now we are going to the next case. Okay, what is that? We are going for, so let me quickly show you the steps. So you must be clear with the slides even. I have kept the material, reference material. I hope you have verified. But again, as I told you, read book. This is just for your reference. Do not rely on that. This is that dependency should not be there. Okay. I hope you have taken you have whatever we have covered in class that you can take as a full reference, right? But whatever is in that material, of course, you should read the books, because we are covering in the class whatever is given in the book, right? So better you take notes, so it will be better to maintain. So I think this B8 and B012 you must be clear with, right? Any instruction that you can take. So this is sufficient. I think this is for immediate to register transfer, and this is not for that. Now we are going for the next case. So this is only the slide that we have covered so far. Okay, now what we are going for? Now we are going for the move instruction between registers and register and memory. So let us focus on the cases. What are the cases that we have? We have move instruction between what? Register to register, right? Then we have memory and register move instruction, 3 cases. Yes, but what about 3 cases? Which are those 3 cases? Yes, Keval, it is correct. But what are those 3 cases? Yes, register to register, memory to register, and yes, memory to register. And so you can, if you will focus on this, no, immediate is okay. Immediate we have completed, na? So we are not focusing again on the immediate. We have completed the immediate case. Now even in register memory, there are three different cases that we can encounter. What are those three cases? As Khushi suggested, that was correct. What was that? Uh, just a second. Just a second. Yes, it is. Yes, yes, they are correct. What are they? Just a second. I'm resharing it. So yes, it was correct. Like what we have options in options we have memory to yes, register to register, right? So what from to, if I write in from to, so from register to register. Okay, this register can be any any combination. From register to register. From register to memory. Right here, so I can say this is to and this is from. And one more case that is remaining is from memory to register. These are the three cases possible, right? Register to register, both operands are registered, right? Okay. So now how this is encoded, let us see. In that also template is there, right? So in that template, B is not there. Instead, first byte, suppose this is my byte 1, 1, 2, 3, 4, 5, 6, and 7. These are my 8 bits, right? In that first few bits are fixed like it was in the previous case. But here the value is first 6 bits are fixed. So it is 100. This is what I was telling you. 100, 10. This is how this first 8 bits are fixed. Okay. Then the next bit is here. This is bit D. I will highlight it with a different color. This is bit D and this is bit W. Okay. Now W indicates what? Again here also that are the possibility that we are taking 8 bits or 16 bit from the register to memory, and register to register, like you, it is possible that you have instruction like move AL BL, or you can have instruction like AX BX, right? So it is possible, or in that way also you can go for the memory. You are transferring data to memory or from memory, 8-bit data you are transferring, or 16-bit. So this W is same as the previous case. Is it word? No, it is not word. That means it is 8-byte. Sorry, 8-bit. And word is, it is not a word, or it is a word kind of thing. That is a 16-bit data. Right? So this is W. I think you or everyone must be clear with, right? Next is what? Okay, let us take this much first. Next is related with this D. In that, what we are having again, next byte. This next byte will have uh, 3-bit reserved for mode, or rather 2-bit reserved for mode. These two are for mode, right? Next 3 is for register, and next 3 is for register or memory. I can explain. Okay, now let me tell you what they are. These two are for mode, right? this 3, this 2, now this 3 are for register, and this 3 are for register or memory. Okay, now um, what is this register? What is this register? So it indicates the same register values that we had in the last case, this one. If register bit is 000, that means it is, if register this, if this 3 are 000, suppose, and W is 0, what it indicates? What it indicates, which register is indicated? If W is 0 and if register bit is 000, yes, it is AL, right? It is AL. Okay, so now this is 0 and this is 0, that means it is AL. So one register is we specified is AL. So that register can be, so now what is so register is specified AL. Same way, if this is 1 and if this is 00, that means register specified is AX when W is 0 and W is 1, right? So that is okay. So what we have specified, we have specified the register. We have specified the register. We have specified the register. Now that register can be from or to both. That means you can take from AL or you can put to AL. It can, that AL it can act as two register. I mean, as a destination or as a source as well, right? So that is indicated by this D bit. What this D bit indicates? If D is 0, then it is from. What is from? That means whatever is specified in register from that, and 1, that is 2. Yes, register, whatever is specified by register is a destination. True. Okay, so 0 indicates that whatever is specified here is a source, and 1 indicates that whatever is specified here is what is your destination. Is it clear? So for this instruction, okay, here right now it is okay. So suppose for this, suppose I specify 000 here for this instruction. Can you tell me for this instruction what will be W value and D value? What will be W value and D value? Yes, D value is okay. 0 indicates from. From means what? It is a source. Okay, so yes, Keval, are you clear with? So W is equal to 0. Why? Because it is 8 bit, and D is equal to 1 because it is 2 AL, right? So this is, I think this must be clear to you. Now what about now? Second operand is remaining, right? So that operand that can be decided by these two mode bits and this R and M bit. Can you give me what are the combinations possible for this mode? What are the options that I have for the mode? Yes, 4 options: 0001 1011, right? So suppose it is 11. Assume with I am starting with 11. Okay, 11 indicates that it is register to register transfer. Sorry, it is register to register transfer. 1 indicates it is register to register transfer. Okay, so register to register transfer, that means second operand is remaining, right? So in that one first operand we have already specified, right? We have what about second operand? What about second operand? So I will write 11 here. It indicates register to register transfer. So second operand we have to specify here. How will we specify BL? What is the code for BL? If you want to see here, what is the code for BL? Yes, it is 011, right? So what it will be 1 1, and then it will be 0 1 1. So from this we will understand, okay, it is register to register transfer, and hence first register, this will act according to source and destination, according to this bit, and this will act as the other register. If this is source, this will be destination. If this is destination, this will be source. Depending on this D bit, you will decide it. Now my question to you, suppose I am writing move ALBL. What you considered that from BL to AL. Sorry, what you no, what you considered, you specified here that that two, what you specified here, if you will read this, so what you specified to AL from BL, that is what you specified, right? What you specified, that here the combination of D and this register specified that to AL from BL. How from BL was specified? Here only. Can I write, like, can this combination be used to specify that from BL to AL? Are these two instructions different? That means I will specify AL here, and these two combination will be used to specify BL. Are this, they are same, na? They are same instructions. Are these two instructions different? From BL to AL or to AL from BL? What is the meaning here? They are same, right? They are same instruction. So what is the case, like if I want to have register to register transfer, I can encode it in two ways. One way is what, that is what I did here, that I specified this register is the destination and this is the source, or whatever I will specify is the source. That means I will write here 0, that is from. Here I will write the code of BL. So that is what it means, that from BL, and here I will write the code of AL. That means to AL. Both the codes are valid. Both the codes are valid. I mean, both are the same instruction. Na? So this combination decides. So instruction is same, but machine code will be different for sure, and both will do the same task. Both will do the same task. So one instruction having two machine codes kind of thing. This instruction is having two machine codes where the D and register combination will specify AL, case 1. D and register combination will specify BL, another register will be AL. Okay, so both the cases are representing move AL, BL, or register to register transfer. That is true for any register to register transfer. Okay, so I think this must be clear to you. Up to this, any doubt that why two codes and everything is clear to you? Any doubt, you ask me, otherwise more complications will make you confused. Any doubt, ask me right now. Should I move to the next one? Different mode is remaining, that we are going to. But right now, up to this, mode 1 is clear to you. In register to register, D is anything 0 or 1. Is it okay? Yes, it can be 0 or 1, but of course, according to that, meaning of this register and register to memory you have to take care of. Yes, it can take 0 or 1 any value. D is for what direction, to or from, right? So whatever you are specifying, this register will act accordingly. Okay, fine. So fine, yes, we are going to the different modes of, that's why I told you that complications are going to increase. But up to this, if you are clear, then we can go to the next one. Okay, so I think everyone is clear here. Okay. Now we are going for memory case. Okay. Now for memory, so again, suppose it is Suppose now we are going for register to memory transfer. Okay, register to memory. So can you tell me for this case what register will be specified? Register will be specified by reg, right? In any case, in this and this both cases, register is specified by this reg. Memory is specified by these three. We will see how. We will see that. But right now, register to memory or memory to register, this whatever the register you have that is specified by this, and the code already we have discussed. 000 is AL if 8-bit and AX if 16-bit. Kind of all the cases that we have taken. Can you tell me for this case what will be value of D? For this case, what will be the value of D? What is D? Is direction. Yes, D is 0 always. For this type of instruction, always D is 0 because whatever is specified, whichever register is specified from that to what, that is remaining question. From that, that is fixed. Okay, so D value is fixed here. And for this type of instruction, what will be the D value of D? This type of instruction, D is 1, right? So this portion is over, right? D value is over. W I think is clear to you, right? W is clear. So what is remaining now? This portion and this portion. Yes, memory part. So combination of this two and this three totally will represent memory. Now tell me what are the options that I have memory for the memory transfer. Suppose memory to register transfer I am taking, or any case, but for simplicity I am taking memory to register. What are the options that I have? Suppose move AX and I want to specify memory. What are the options that I have? I will specify like this. Which mode is this? Direct mode. What are the other options that I have? Index mode is there. Then indirect mode is in that displacement you can specify, right? So many addressing modes will come into pictures now, right? Addressing mode is going to come into picture. Fine. So for that combination of mode and this is going to specify all the addressing mode. For that you will need a table. For that you will need a table, and this is that table, right? If my if my mode value is 00, and if R and M field indicates 000, that means it is Bx plus Si. The value of Bx plus Si you have to take, and that will give you the offset, right? Then you might need what we can say, suppose that mode value is 01, specified R and M value, mode value is 01, this is 01, specified mode value is 000 here, I mean R and M value is 000, that indicates that it is Bx, Si and 8-bit displacement, right? Bx plus Si and 8-bit displacement you are specifying, right? Same way, if you are going for 10, then Bx, Si and 16-bit displacement, right? So of course we are going to take the cases of all, but suppose I have to specify, so suppose I am specifying this, Bx and Si, summation of Bx and Si will give me the offset, so it will be 000 So this is just 2-byte instruction, right? But suppose I am going for mode value 01 and this value 000, that means it is Bx, Si and 8-bit displacement. So it will be how many byte instruction? 0 and 1, and this 00 will indicate one more byte is 8-bit displacement is needed, and that's why it is 3-byte instruction, right? Because 8-bit displacement you have to specify, additional immediate data that we are specifying. If you want to recall, like it is like instruction is like what you can say. Okay, we will take the case, so at that time we will be more clear. And if I want to specify 16-bit displacement, what is that? Bx plus Si plus the 16-bit value is added. Together it will make offset, right? So all those addressing mode you have studied, but yes, that you have to remember. So suppose it is like just you said, someone said yes, Priyank said that it is Si. So for that, if I want to write Si, so what will be my mode value? It will be 100, and Si will be indicated by mode 00. So RNM value will be 100, where it is. Yes, RNM value will be 100. This will be 100, and mode will be 00. So mode will be 00, and RNM value will be 100. That means you have to take the data from that SI. So this is the entire table, right? Direct addressing, if I took this case, what was that? Yes, this one. So in that case, what is mode? In this type of addressing, what is mode? So if you will see here, mode is 00, and my RNM value will be 110 and 16-bit displacement. So how many byte instruction it will be? Mode is 00 and this will be 110, and so what it indicates? That it is move, right? This will be W will be, so okay, let us code for this, so it will be even more clearer to you. Code for this, what will be move AX, what will be the value of D, what will be value of W? First start with this. Let us complete entirely for this, then we will go to any other case. Okay, first 6 bits are fixed. What are those? 1 0 0 0 1 0, right? D value, yes, D is for 2, yes, 2, and W is 1 because 16-bit operation, correct. What about register bit? Register 3 bits. Yes, they are 000. So yes, 000. What about this bits? What we can say, this mode and this. So what it is? Direct displacement is to be specified. Displacement of 16-bit. So what is my mode value? 00. What about my RNM value? RNM value. This is mode. This is mode. And this is RNM value. RNM will be 110 and mode will be 000. Yes, so RNM value will be 110, and what about mode? Mode will be 00. So we have specified, okay, it is 16-bit operation, it is move instruction, and it will have direct address. But we have to specify the address. How will we specify the address? What will be the next code? 1 2 3 4 I have to specify, na? Otherwise, how it will come to know that immediate data will be the 16-bit displacement I have to specify? So should I write 1 2 or 3 4 first? 1 2 or 3 4? Just 3 4 first. So I'm not writing it in binary, but definitely 3 4 hexadecimal should be written in binary, and 1 2 in binary. So how many byte instruction it is? Yes, is it 16 byte? How many? 4 bytes. Yes, it is 4 byte instruction. True. Okay, now quickly do for move AX comma BX. Quickly move AX comma BX. Do you need table? First tell me about first few bits. First 6 bits are fixed, right? 100 010. What about D? what you are doing for, let us have one case. Okay, 10010, 0 or 1, but what you have opted for, Yash has taken something right here. What he has taken, 1 1, that means he has taken 1, that is register mode. So he has taken 2 2ax, right? In that he has started with 2ax. So let us start with that. Yes, all of you are taking that 1 1. So okay, so we are taking it 1 1. What it indicates? 16-bit operation. And this indicates whatever will be specified by to register, that will be 2. So that is 2. Yes, it is for so we, this register bit will indicate 000, that indicates ax, and that is 2. Yes, it is 2ax. What about this mode? Mode will be 1 1. And what about this R and M mode? So it will be another register. It will be not 0 1 1. I think you have missed it. It is, yes, it is 0 1 1. I missed it. Okay, it is 0 1 1. True. It is 0 1 1. Correct. True. So it is done. That is absolutely correct. This is fine. So what is alternate option? Quickly. What is alternate option? I'm alternate the code. Give me the alternate code of the same instruction. It will be 0 1 and 0 1 1 and 0 0 0. True. Absolutely correct. Janil, I think something is remaining. You are working on. Right. Okay. You specified the important ones only. Right. I think all of you clear. Na? There's these 3 bits um, are interchanged. 0 1 1. So here I think I've written many bits. So this 3 and this 3 are altered. This will become 0. True. Correct. Now let us go for one more instruction. Move SI TL memory to register to memory transfer. I mean register to memory. What will be that? First 6 bits are clearly seen. What will be D bit? What will be D bit? D bit will be 0. 0 indicates from register. So D is 0, correct? D is 0. What about W? W is also 0. Why? Because it is 8-bit operation, correct? What next? What about mode? Do you need the table? What it is quickly? Okay. What about the mode that you opted for? What was the mode? Yes, all of you have taken 0 0. It was a 0 0 mode. Yes, true. Then this you have to specify CL, whatever the code for CL. What was that? Code for CL is 0 0 1. Yes, it is 0 0 1. True. And what about this 2SI, right? 2SI. So for that it will be SI is indicated by 100. So that we will write here 100, right? So it is correct. So your answer is correct here. One more question, displacement. I think you must be clear with the displacement. So let us take the extreme case. Move AX 1 2 3 4 H bx. What is the meaning of this? Si. What is the meaning of this? How to calculate offset? How to calculate offset? Yes, bx plus si plus 1, 2, 3, 4. So just tell me. I'm not going to solve it totally, but can you tell me what will be the mode and RNM value from this table? Bx plus si plus 16 bits. So what is the mode of that mode and RNM value? Mode is 10 and RNM value is 000. So I think you are clear with it. No? That's good. That's absolutely great. Okay. So this you will complete. Of course, solved solutions are given in here. Also, we have discussed something, but solutions are given in the book even. Right. So we have considered this to memory from memory with the displacement. This thing is remaining yet. What is that? It is possible that you so far what we were having, that suppose I was writing si here, right, or I was writing in this case, suppose we did it here. What was a segment address? What we have taken as this is offset. What about segment address? Where exactly it will go to? Offset is not alone sufficient to identify the location, right? So it will go to from CL to SI, but it is offset SI. But what about segment? At which segment? Offset of which segment? Suppose it is SI, then by default segment is data segment. But what if, yes, true, it is data segment. What if I want to specify my specific segment? Then suppose I want to go for offset SI, but not in data segment, which is the default one. But I want to specify, no, go to ES segment value, take offset SI, because SI is just a value, right? So I will write it like this, but how to encode it? Yes, that is true. I will specify it like this, but how to encode? For that, I need a prefix, a byte prefix. What will be that? Otherwise, it will be the same coding like this. The entire coding will be same as like this. One byte will be extra, and that will be prefixed to the code. This was the code for this. There will be extra byte which will indicate the segment address is not the default one but the specified one. Okay, what will be that byte? That byte is given as I can show you that. What will be that? In that byte has first few values fixed. These values are fixed. This first value of that byte and this last value of this byte is fixed. Okay, and these two bits specify. If it is 00, that means ES. If this is 11, that is DS. If 01, then it is CS, and so on. S10, then it is SS. What is the case like here? If I want to have this instruction, in that default segment will be data segment. So if I am just coding it in the previous case, this will be your answer. As we were doing it in the previous till time, what we did is, the whichever instruction we did so far, in that way if you will do, you will get this answer. And in that way, basic segment will be taken as data segment. But if you want to change it, you don't want to take data segment, you want to take it as what you can say, the stack stack. You have to take stack segment you want to take. Then you have to take what? You have to have one extra byte you have to add, and that in that this value and this values are fixed. This value will indicate what is the segment. You have to take segment 10. You have to write it 10 here. So and it will be followed by remaining instruction will be followed by as it is, as we have taken in the previous case. Okay, so any doubt so far in this case? So what is your job? To try with move AL. Okay, you can try this even. Your task is to try with move AL ES DI. Okay, Try with this. Come with the code, right? We will discuss this code quickly and then we will go to the next topic. Write down this question, solve it, just write this machine code and we will solve this question and then we will go to the next topic in the next lecture. Any doubts so far? Okay, so we will continue our discussion in the next lecture.